One of the features that I've been wanting to bring to vectormathplayground.com is matrix support. Matrices are very important within game development, graphics programming, physics. It's because there are many use cases for them. Oftentimes a character or an AI within a game, their translation, rotation, orientation, that's all represented by a matrix. And other times, if you're trying to do collision detection, it's useful to be able to switch between different coordinate systems. For example, if you want to detect if an object is intersecting with a box or something like that, you may want to translate or transform an object from world space into local space, where you can easily detect if it's within the bounds of a box or not. There are many use cases for matrices, and one of my goals for Vector Math Playground is to allow developers or anyone interested in vectors and matrices to visually prototype these different ideas before they start writing code. So I'm really happy to say that we have our initial support for matrix operations now built into vectormathplayground.com, and it's live, it's ready to go. So what I want to do is I kind of want to walk you through how matrices work within vectormathplayground.com, and as always, you are able to create and perform operations on matrices through both the GUI and also through command line if you are interested. And if you don't know how to bring up the command line like I just did, you just hit your tilde key on your keyboard and it should pop up. If you are on a mobile device and for whatever reason you want to use the console, you can also do it by going through the menu to commands, and then you can come down to console and open, and you can close it this way as well. Alright, so let's talk about matrices. So let's start by creating one. What I'm going to do is I'm going to clear out our scene, and we are going to create a matrix. The way that we do that is very similar to the way that we create vectors. We're going to go up to scene, and then we're going to go to the matrix category. And you'll see you have a couple different ways that you can create a matrix. The default way is just to create an identity matrix, and here you'll see we have 4 different columns that you can fill in. You can, by default it is an identity matrix, but you can fill in any values you want here. Alternatively, if you have a vector somewhere in your scene and you want that to be the forward basis vector for your for an orthogonal matrix, you can do that here by just selecting a vector, forward vector to base your orthogonal matrix on, and you can create it that way. But what we're going to do is we're going to just stick with the default way. So we are just going to create a simple identity matrix. Click create, and voila. It doesn't look very different from our general default scene setup, except you'll notice that there are no names being rendered for each one of these vectors, and that's because these are not vector objects in the scene. This is actually a matrix, and so let's see how we can manipulate this. So if we go up to menu and we go to matrix operations, again it's very similar to vector operations, except we are applying operations on a matrix now. Let's rotate this identity matrix about the up axis, this particular vector here. So what we're going to do is we're going to select our matrix, and here we're going to specify, do we want our angle to be in degrees or radians? For me, oftentimes it's just easier to work in degrees. So we are going to rotate backwards about 10 degrees. Click rotate, and look at that. We have a rotation matrix. We don't need our old identity matrix anymore, so I'm just going to go ahead and get rid of that. So let's see here, matrix, destroy. Let's get rid of the first one, and let's give our new matrix a somewhat helpful name. Our mat So for rotation matrices, I promise I don't normally write my variables this way, but in this case, you know what it is. It's a rotation matrix. So we're going to update it. And let's see, what can we do that's interesting with this rotation matrix? Well, to start with, why don't we combine some matrices? So what we're going to do now is we're going to translate this matrix. So we can do that by coming up to matrix operations, translate. We'll select our matrix and let's move it forward by, say, 2 units. Translate. So you can see here we still have our rotation, but we've moved this matrix up by 2 units. We've moved it forward, I should say, by 2 units. And now let's do something else. Let's try scaling this matrix. So come up here to scale, select the one that we just created. And let's scale it by 3 units. Let's be dramatic. And there you go. You have a scaled matrix. So yeah, I think this could be quite helpful in visualizing. And again, you know, your matrices, they don't need to be orthogonal. You can create whatever kind of matrix you want. I haven't actually tried creating like a perspective matrix with this, but you can if you want to do that. But this is what you should expect to see when you create matrices. So let's reset the scene for a moment. And let's get rid of these. Actually, let's clear the scene here. But this time, let's actually use the command line to do something interesting. So we'll come in and let's create an up rotation matrix. We'll call it RMAT. We will set the next parameter to true. It's basically is the input angle in degrees, and like I said, I like to work with degrees, so yes, they will be. And we'll rotate by -10 degrees. And there we go again. You can see that this is a rotation because it's not, this forward axis isn't lined with this line right here. So this is a rotation matrix by -10 degrees. So everything looks good. Now what we're going to do is we're going to create a brand new forward vector. So we're going to come up here, and you know, I just find it a little bit easier to do it this way for creating new vectors. We're going to call it forward. Make sure it's pointing down the forward axis. Give it a different color, maybe a nice purple. Sound like Bob Ross now. Let's see here. That looks good to me. Alright, so we've got our forward vector here. So what I'm going to do now is I'm going to move this vector, this forward vector, by 2 units. So come up here and we will go to vector operations, move along, and yeah, we'll choose 2 units. So that's the new vector. So now what we're going to do is we're going to get rid of this old forward vector. We don't need it anymore. So let's destroy it. Sounds horrible. Okay, so now we've got this vector here, and what we want to do is we want to rotate this vector based on this matrix. So we're going to apply this matrix to this vector, and we're going to see what happens. Now I can obviously do this through the GUI here. I can multiply any vector in the scene by any matrix in the scene. But again, I'm going to do this through command line. So I'm going to multiply, and by the way, if you don't want to actually type out an entire command, you can just hit the tab key and it will try to figure out what command it thinks you're trying to type in. So that's kind of a handy shortcut. But yeah, so actually before I do that, let me list the vectors that are in the scene. Okay, so we've got result, and let's list the matrices. Alright, so we've got our mat. Okay, so we are going to multiply the result vector by the rmat vector. And let's just pay attention to this, see what happens. So it rotated this vector based on this matrix, and this is the result. So now we can do something kind of cool. Let's go ahead and put in that previous command, but we will use our handy dandy $, which basically means, hey, whatever the last thing was that we created, whether it be a vector or a matrix, use that for this parameter. So in this case, this $sign would represent this vector here because this was the last thing created. Alright, but we will rotate that by the same exact matrix, and let's see what happens. Oh, look at that. So we got another vector here. Hey, why don't we just keep going? Look at that. That's pretty cool. Is that what you expected to happen? So, you know, this is pretty cool. I mean, this is handy, you know, like let's say that you're new to game development and you want to rotate an object off the origin, right? And you may, for example, go ahead and compute your rotation matrix, right? So in this case, we did a -10 degree rotation matrix about the up axis. If you're doing graphics programming or you're working with shaders, you could go ahead and pre-compute that. You could put it in a constant buffer, right? And then you could continually use that matrix. You could multiply that matrix by any new incoming vectors, and you could get some kind of effect like this, where you're rotating outside of the origin. Which is pretty cool. I mean, this could represent a ton of different scenarios. I mean, maybe you have a character who has a special attack, and all of a sudden he, you know, throws fireballs in every single direction, right? This is one way to visualize that, right? This could also represent sort of a force field, or it could represent sort of a splash damage. There's a ton of different things that you could use these matrix operations for to visualize different things. Alright, so next we're going to do something similar to the previous demonstration, except this time we're going to use a model. So we're going to do what we normally do. Let's reset our scene, let's clear it. Alright, now let's place a person in our scene. Man, have him look down the forward axis, and we'll choose the render mode of a man. We've created him. Okay, so next let's create a matrix. So we're just going to create a standard identity matrix. Next, we will rotate that matrix by the up axis. So we will rotate him, say, 90 degrees, negative 90 degrees. Alright. And then we will delete our previous identity matrix. We don't really need that anymore. And this is the matrix we were expecting to generate. This is the identity matrix has been rotated negative 90 degrees. So in a counterclockwise fashion, and you can tell because this blue vector generally would be it is the forward vector. Generally be facing or aligned with this line right here, but now it's been rotated counterclockwise 90 degrees. Okay, so next let's move this person out a couple of units. So we will go up to vector operations, move along vector, choose the man, move him by 2 units. Alright, now let's apply this matrix to this vector. Okay. Remember that the models, whatever their starting XYZ coordinate is, that's interpreted as their position in 3D space, and then the index in Y and Z, that will be the look direction. Okay, so let's see what will happen when we apply this matrix to this model. So let's go over here and let's do multiply. Aha! Was that what you were expecting? That's what I was expecting. because this model has been rotated 90 degrees about the origin, right? In a counterclockwise fashion. So that's exactly where he should be. Now let's rinse and repeat this for a moment. So we will go to multiply, take the new, so we're going to multiply this newly created man by the same rotation matrix. There we go, there's our result. Alright, let's do it once more. Go, looking pretty cool. Now, one of the new features that we've added in Vector Math Playground is the ability to render the distance between any two vectors. Now, you can already do this through the scalar operation. So if you go up to scalar operations, distance between two vectors, let's say I want to measure the distance between this one and this one, I can select one, select two, and compute, and then there is our distance between those two vectors. But sometimes it's useful to be able to see it visually. So we can achieve that in a very similar way by going up to vector operations and down to render distance between vectors. We'll choose the same two. And now we have this nice line here that represents the distance between the two. It'd be helpful if maybe the color was a little bit different, so let's change that color to something that stands out a little bit more, maybe blue. See how that works. Yeah, that's a little bit better. Alright, so that's pretty handy. That's a useful tool to have. So let's try one other demonstration. So what we're going to do is, again, we will reset our scene. Let's clear the scene. And this time, let's use another model. It's man's best friend, the dog. Let's see. Create a dog facing the forward axis, and we'll create, there we go. There is our dog. Okay, now let's create a matrix. We've got our identity matrix. We are going to rotate it about the up axis, and let's say let's rotate it 45 degrees. All right, and then let's translate that matrix. Let's translate it by, say, 2 units. So that's our new matrix. And see, this was the new forward vector. This is the rotated forward vector. So it went 2 units this way. All right. So now let's scale this. So let's take our newly created matrix and let's just scale it by 2 units on each axis. And then I'll delete the previously created matrix just for clarity. There we go. Okay, now let's apply the dog to this matrix and let's see what happens. So we're going to come up to vector, multiply dog by that. Voila. Is that what you expected? So basically what we've done is we've rotated the dog here 90 degrees clockwise, and then we translated that matrix by 2 units. So that's why our object is now offset. Our dog has been translated to this position, and then we scaled that matrix, and that scale has been applied to the model as well. So yeah, that's just a handful of some of the things that I've been working on vectormathplayground.com. I hope that you find this helpful, and I hope this will help you visualize matrices. I'll continue adding more features to the matrix support, and I'm still planning on adding quaternion support as well, because I think it would be really helpful to be able to visualize quaternions in 3D space as well. So, alright, I hope, like I said, I hope that helps you, and if you like this video, please hit the like button and please subscribe. But either way, I will be posting new videos in the future, any updates that I do to this tool, any new features I add. I'll have some tutorials on just basic general 3D math and how to use this tool to visualize that. And yeah, so thanks again for watching. It's Thanksgiving Day where I'm at, so I'd like to wish you a happy Thanksgiving. All right, thanks.